What up, boys and girls, ladies and gentlemen? Jesse Warden here. It is Sunday, June 4th, 2023, and today we are going to talk about just one topic, pure core imperative shell. It is a technique for testing and for architecting your application, irrespective of what framework you're using, and it's applicable to both back-end and front-end code. And I wanted to talk about it mainly because I have realized why in Elm I never write many unit tests, and in JavaScript I write thousands aside from types. And a lot of people who are doing front end tend to follow the same trap that a lot of the Java and C# developers of just using way too many mocks and not really understanding why they're using mocks, causing a lot of maintenance burden, and I don't think it's necessary. I think if they focus on the unit tests that are just stubs only and just doing pure functions as much as they can with a little bit of side effects that, you know, have conditional logic, right? So very, very few, if any, mocks. The actual running of the side effects is done in acceptance tests. That's where you verify it actually works. And so if you look at something like Elm, for example, as opposed to JavaScript or Python or Ruby or any of those other languages where there aren't any side effects, the only way you know if the app works is if you actually test the web browser app. Otherwise, if you're doing business logic, you need the unit test for it. Where in JavaScript, not the case, or in Python, not the case. You need to run those side effects. So I wanted to show a really good video that illustrates this from a Ruby perspective, but it's very applicable to us, for example. So if you Google, let me see if I can make sure I'm Googling here. If you Google pure core imperative shell, there's a variety of topics on it, but this one in particular, the guy who did the JavaScript What video, he actually has a really good example on how you architect any application. Now, I want to point out that Ruby is very similar to JavaScript or Python, where it supports imperative style, it supports object-oriented style, and it supports functional programming, and it also supports all three mixed together. So it doesn't matter what paradigm you're using, but it's important to understand the concept because it makes, in my opinion, your unit test a lot more focused and easier maintainable. And then the side effects, and you want to verify your app works, you do an acceptance test. So I'll put this link in the description of the video at the end, but it's, if you just Google functional core imperative shell, he gives a really good example of it. And from a front-end perspective, I'm going to show you some unit tests from a back-end perspective first. But from a front-end perspective, you utilize all the tests from running the logic to doing your interactions, things like that in there, whether you're using React or Vue, doesn't matter. On the back end, the same thing. It's all the pure functions, as pure as you can possible. You kind of push the side effects to the side. And at the very end, you have one function or two or whatever that actually implements the side effects. 99% of this is done through dependency injection. So dependency injection, if you're not aware, is where you pass the dependencies to a function or a class through the constructor function or through parameters through the function. So if you look up dependency injection, you'll find a ton of overcomplicated examples. But from a functional programming perspective, it is a function that takes parameters. From an object-oriented perspective, it is a constructor that takes parameters. And I have a YouTube video, if you look at Jesse Warden TDD examples. I have two examples I'm doing, both from OOP and whatever, both the blog post and YouTube playlist series that shows how to do that. So assuming you understand dependency injection, then at the unit test side, you can give them fakes or stubs, right? I don't care what test double you call it, but if you look up test double, Martin Fowler and others like to use the Wikipedia definition. And if you scroll right here, it says types of test doubles. Most of the time, I just use a test stub. It's just an indirect input where it's always the same response. And so a lot of times it's very similar to when you have a function that always returns true or always returns undefined, very similar to console log. That's what I'm talking about. Things that most mocks are in JavaScript and Python are really spies because we're more interested on how they were affected after the fact. So these are the kind of things I'm talking about we should stay away from, is basically verifying the indirect output. That means that if you call a class method, you don't know if it worked. You got to go look over there to some other random thing. If you're doing the same type of thing with functions, you call a function, but you don't care or know if it worked. You got to look at this thing over there, right? So you're asserting indirectly. Most of the easiest way to unit test is pure functions. So if you maximize how many pure functions you have a bunch of benefits. The first is easy to test. Second is predictable code. And third is a lot more maintainable code and test because you don't have all these mocks everywhere. You still have stubs. they're frustrating. You try to push those to the side and focus really on the actual pure function components that you want to test from a front end and back end perspective. But eventually you're going to have some kind of side effect injected in there. So that's what we're focused on. Things like fake objects and dummy objects are very similar. When they say fake object, they really mean like systems, like databases or Postgres or things like that. And that is very wishy-washy because data is very hard. So we're not talking about that. We're really just talking about avoiding mocks and focusing really just prioritizing stubs. Okay. So let's show you an example of what I am talking about from a actual development perspective. So we have in the API, and I'll show you some front-end stuff after this that's a lot more complicated, so we'll briefly cover it. But from a back-end perspective, whenever you're doing something in AWS, whether you're using EC2s or Lambdas or whatever, you log errors. And typically, you want the errors that you want to know about to have a very specific shape. So you have intentional errors. These are things that you know are failure scenarios that you couldn't handle. So imagine the really dangerous paths in your JavaScript where it's like, hey man, I really need to use a try catch around this, or a dot catch and a promise and log it out. It's really important I know about these scenarios. You can put a simple string shape in your log, your console log, and AWS will let you know through CloudWatch. You can set up alarms for it. And it's very important because these alarms will, as soon as it happens, will proactively tell you, typically through a text message like on your phone, or through an email, and you'll know about it before your customers do, before your boss does. Unfortunately, sometimes before your customers do, it can go to Slack. It doesn't matter how you wire it up. The point is that you're being proactive about this from an observability perspective. You know if your code breaks, and you're very intentional about it because you know what that error means. You know where you put it. You know where to put it in the code. You took the time to provide context. The error says unknown error. That doesn't help you. It says, this is a known error at this location with this information. Go look here. If this happens, it could be this, right? So you don't want to cause fire drills at 3 a.m. in the morning when your phone goes off because you're on call and your server went down and you're like, what's going on, right? Or if it's a Lambda, you're having an increase in uptick in errors. You don't know what's going on. So you want to be intentional. And the reason this is interesting is that although it does use console log, that's a side effect, but it's a really easy one to play with because it's not asynchronous and it returns undefined all the time. So it's one of the easier side effects to test. So let's take some of the code I've already written here and I'll copy and paste it in and explain it. We're not going to deal with the whole TDD today. So this log error function, it's very similar to any type of logger, whether you use Winston or any of the other Node.js loggers or the Python loggers, where it's you create an instance that you've configured, whether it's class-based or function-based, and it can have a different set of places those logs go. It can go to multiple places. It can go to a file. It could go to standard out. It could be transformed. The point is you have a single place that transform your logs. And most of the time, it's JSON formatted. The reason it's JSON formatted, everyone and their mom can parse JSON. So it's a great transfer format. And you have a chance in heck of reading it at 3 a.m. when you're tired. So that's why it's really, really beneficial. So what we're going to do is we're going to log an error that we got and attempt to parse or understand it. Now, we can improve this function, but for now, this is a quick and dirty to get her done from I'm trying to create observability, and I only have one day to write the code for it and check it in and hope it works. So we're going to take any type of error object, which could be any exception you got from a dot catch or from a try catch, throw it in there, and we're going to give it a logger. This logger is the only interface for now is that it has a log method. Okay, so we're not using interfaces in JavaScript. We don't have TypeScript or anything like that. But the convention is that it has log. And the point of log is that it sends it to someplace else. It sends it to standard out, sends it to both, and we know about it. We know that format. And so we've got to parse it. And so from a pure function perspective, if you've never done test-driven development or even just unit test after the fact, the only 3 things you have to know to write unit tests are you take a function and give it some inputs. You then capture that output. You then make an assertion that this output is what you expect based on these inputs. Make sense? So we're expecting that we want to see this kind of error inside of our Lambda logs. And the reason that's important is that usually if you take this string right here, including this space, so all caps, error, colon, and then a space, you can put that in the regular expression for your Lambda alerts, and it'll go through every single log message for every single one of your Lambdas and tell you, if it finds that error. So if we format it this specific way, it doesn't matter if it's JSON or flattened strings or whatever, it'll find it, which is fantastic. When it finds it, whether it's an Elk or CloudWatch or whatever, Splunk, whatever system your logs go to, we can be aware of it, and that's fantastic. The only thing we want is error with some context. And most errors, usually, whatever you put in the constructor, it'll put that as the dot message sometimes. There's a lot of other different types of error objects that come out. Some libraries emit objects, their own custom errors. It's very strange. So you got to be a little flexible, but it's JavaScript, so it's a little easy to be flexible around objects and stuff. So that's the basics. That's why we like pure functions, because same input, same output, no side effects, except this one has side effects. So how do we test side effects? Well, we have to have some kind of stub set up. A stub is, from the test double definition, it just always returns the same output. And so our stub looks something like this, where every time you call log, it's going to do console.log, log somewhere. Now, we're using unit test. We don't want a ton of console logs polluting while we're trying to figure out why tests aren't working and things like that, right? So we're going to have it actually not do a console log, not do standard out. We just want it to know that it called log, which is fantastic. So we hit save, rerun, and we see that it passed our test. Fantastic. So let's go in log error and see kind of what we've got going on here. So we've got a message string, and it takes the error and attempts to get the message off. You'll notice that it's got the nullish coalescing, not the nullish coalescing, the optional chaining operator. If we don't find it, we give it an unknown error. Now, this is not good. This is just from a TD perspective, get the basics working with basics known error handling. We'll improve it later. Now, your functional programming Spidey sense alarm bells should be going off here because logger.log does not return a value. And so that means it's doing a side effect, which is bad. So we don't like side effects, but whatever. The core logic that we're really testing in this function is this. So we could remove logger, but we'll do that in a minute. I'll show you what I mean by that, from pushing the side effects to the side and having one dude do the side effects. But this is the simplest example I could come up with. So we return that message because what we're really interested in is, did you format it in a way we expect? We're going to assume here that the logger, console.log, Winston, some third-party library, whatever is working. We're not really interested in the side effect at this point. So it's going to work, okay? So that's really what it does. It just takes this error message, formats it. Now, what does it do when it doesn't understand this? We have objects, or somebody just throws a random error, or the string they created didn't work. Well, we have a separate test for that. So let's look at the unhappy path. The unhappy path is if we go to, let me find the other one. It's on the other screen here. There it is. Yeah, so if we pass in no string to the constructor of an error, it'll give us back an unknown error, right? And that's good, but we want to test for that. So let's make it fail first. We'll remove the period just in case, and it should compare and say we're expecting a period, which is fantastic. So let's add the period, and it should turn green again. Fantastic. Cool. So we've got the happy path of we give it an error with an intentional error of context that we wrote or someone else wrote from a library. Or we don't know what it is, but at least we get something, and we can start adding things such as what function did this come from, what module, what lambda, what server, what region, blah, 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 all the other stuff we want from a logging perspective to be in there. The business logic of, is this error message enough that if I'm exhausted at 3 a.m., and I see this, I know what to do, or I know to go back to sleep. That is a start of your acceptance tests, okay? So we'll talk about that in a minute, but remember what I just said. Do you have enough information to not panic when you're out of it at 3 in the morning, okay? So from a unit test perspective, we verify that this function's creating the strings, formatting the strings, and we can enhance this later with the different additional unit tests, such as provide functions, provide modules, things like that, which may change the API, and that's okay. We're exploring. So normally your API should be set and you should be done. Your test should be changing, but we're figuring this out. We're figuring how this little function is going to help us out here. So let's go take a look at how do we verify that it actually sent the log, because this function doesn't do one thing, it does two. So the original idea for this function was to start as gleaning error information from an error and then adding context that we find information. Some of it can come externally. We could give it a date to let it know what happened. It could generate its own timestamp. Who knows? We could tell what module. There's all kinds of things we can add. But once it has that information, then it sends it. And so it actually does two things. Now, it's a very, very minor two things. And if you look at any functional programmer or even a programmer, they find the idea of stubbing their logs ridiculous. But this log is how our entire observability system over our application or applications works. So it's pretty important to get it right, not just from a test perspective to verify that we've got the business requirements legit and we agree on this contract of string. We're going to put in all our logs when something messes up, but also from an acceptance test that when we release new code, we know we didn't break our observability. So those things are really, really important. So when they're talking about log, and they mean like console log, they don't mean like a logger that sends messages, okay? So we don't own this logger. It doesn't return a value. We just call it, pray, does, assumes that the contract is it returns undefined. It doesn't throw any errors, and we just move on our day. Now, there are a lot of people who do testing who don't do integration testing, which nobody knows what that means, end-to-end testing, which is very hard to do, or acceptance testing. So I'm going to group all three of those together. Those are the types of tests that I need to have my wireless on. I need to use the website. I need to have the database up. I need to be in an environment, right? They are the ones that really test, does the application work as the user expects it? The user in this case would be me as the developer maintaining this application. Does it actually send an error message, put it in the logs, and then I can hear about it when my Lambda logs trigger? How do I test that? Well, I throw an error, and then I listen for the SNS to come back from AWS. That would be the acceptance test, right? As a developer who's on call for this application, I want to be aware of errors that occur in this application so that I can either react to them or go back to bed. That's the acceptance test. A lot of developers don't know how to do that, or they have a really horrible, myself included, experience from doing end-to-end tests and acceptance tests, and they're a pain to maintain, and they just don't like them. So what they end up doing is not doing them, which is awful. And they'll often compensate in their unit tests using side effects. Thanks, headphones, for just magically appearing. I appreciate that, weirdos. And so the reason they do that is they want to verify the second part of this function. Did the logger actually work? So what they'll do is they'll whip out the mocks and verify, did you call it with what I expected? Now, there's a lot of horrible things here, but let's copy this guy, and I'll show you some of the pros and some of the things I absolutely loathe. So we have a completely separate describe here, which is showing the side effects. To do a mock or spy, it needs to be stateful. It needs to be aware of what happened to it. So right off the bat, I don't like it as a functional programmer because this thing has state and is non-deterministic. It can change over time, so it makes it unpredictable by default. So you got to be very, very careful. If I didn't use it, I wouldn't have to be careful and I wouldn't have to worry about it. So I know it's a bad joke, but it's also true. Like if you didn't use mocks, you wouldn't have to worry about mocks. So now we have a mock that has all the problems of a mock, right? It has statefulness. It has an implementation detail. It's assuming that's how Winston works. Maybe Winston doesn't work that way. Maybe Winston log does return a value. Maybe it does throw an exception. Who knows? So there's a lot of assumptions here, but the good news is we've made it as small and as readable as possible. One line. So there's no deviation that, look, man, we're not trying to recreate every single feature of Winston here or a logger. It's just a function, and that's it. We don't care about parameters. We don't care about return values. It's just a simple Jest mock that has things that we can know about it. So we've done the best mock we possibly can. It's small as possible, focused on just this test, right? So when we log it, we pass it in. So it's not a stub anymore. It's an actual mock. And technically it's a spy because we want to know things that happen to it. So your first thing you should notice here is that log error no longer returns a value, which should send your spotty tingling, and it's doing a side effect. Well, that's what we're testing for. It's testing the side effect. So what we're interested in is, did that instance of log for this mock, did it call with the error? Because if it was, then if it's Winston for real, then it's going to take that actual string and send it. So this makes us doubly sure that not only did our function convert the error the way we wanted from a happy and unhappy path perspective, but it also utilized the side effect in a way we expected. Now, here's where I have issue, and I think that pure core imperative shell really helps here. I don't think we should be doing this in unit test. I think we should be doing this in acceptance test. So anytime where you see this, replace it with a real Winston logger and go test it in an acceptance test. Problem solved. two things. A, you no longer have to maintain your mocks. You're using a real Winston logger. Number two, it tests if your application actually works. So that's how we do it. Now, from a pure core imperative shell perspective, the way we can kind of get around this is now that we have test running, you can see we've got our green blue here. Let's hit save. I'll show you the actual error test running 3 past from our side effect. What we can do is we can say convert error message, and we'll take our error. We'll take our string out here, pass it in, and we'll have a very focused function that just does the business logic. So you do that with everything. I'm going to show you a bigger example here. We're not going to test it, but I'll just show you an example of how you do that. So this now has one dude to handle the side effects. This is the core of our business logic, this convert error message. In some languages, this could be a private, or in this case, a function that's not exposed publicly in the module. If you're doing class from an object-oriented perspective, this would be your private, and your public, test your private in like a roundabout way. But this is how we want to do it, is that this is a pure function, and we can continue to make this have all kinds of interesting information for our log and add a lot of information like timestamps, region, what service it was being used for, and all that other stuff. And it's a lot easier to test because we just give it an error. So we just give it some data and then assert on the string that comes out. The actual side effects, that's really like the core of the application. And this is a third-party library, so we don't want to test the third party, right? So if we keep doing this, eventually we'll have a bunch of pure functions. Now, this is an example that only has 2, right? A logger. So let me show you a Lambda example, and then we'll quickly bounce over to the React stuff. So if I take this from a JavaScript perspective, a lot of times you'll see Lambda handlers that look something similar like this. They have an event, they do a bunch of stuff, and let's pretend they're getting called from API Gateway. You would then return a status code of 200, it worked, some kind of body that's a JSON, let's say stringify of a yo, man. And that's it. So we have that in there, and that's our unit test, and we just verify that this works, right? Based on saving that out, right? Not a big deal. However, the handler needs to do a lot of things. So the first thing that most Lambda handlers do if they're not utilizing API Gateway is they have to validate the user. So you would have some kind of user validation thing that's probably async. So wait for it. Validate user based on the event body. So event body, the body is the actual post message that your browser would send or your postman would send or some third-party API would send. That body's going to have probably the user in it and the header. So we'll just give it the event and let it figure out how to do that. So if the user is legit, great, then you can do this. Otherwise, you now have to send a 400 back because the user's not allowed. And you're just not allowed, you're not authorized. So assuming the user is legit, what is this? Well, this is probably a service that either A, calls the AWS Secrets Manager, gets a secret key out, validates the JWT with it from your header, and then says, all right, this user is legit or not. Or could call Cognito, or could call some third-party service. Bottom line, it's a massive side effect. So we have to pass that in somehow. So now we have a Lambda handler that needs, a second parameter. And the issue is that all Lambda handlers have event and context. That's their function signature. So now we have to make this a private function. So we're going to call this our method that's get some data. So we'll just say get some data. And we'd be writing tests first for doing this, but I'm showing you the example. So we've got a side effect. We need to inject it. So we can test this function, or we can give it the real one when we start pushing these side effects to the side. The second thing it needs to do is utilize that user and go get some data from that. So we're going to get some data, await, from probably Dynamo. So we'll use the AWS Dynamo connector, and we'll just say get query Dynamo, and we'll just wrap how we do all that. So query Dynamo takes the actual user in. So we'll say event and parse it off at the JWT for there. So it's going to query Dynamo based on that user and say, this user ID has this data from Dynamo. That's going to take a minute, hence another promise. Return it back, and now we have some data. That's cool, and then we're going to parse it. So parse for HTML, in this case, JSON delivery. Because sometimes we don't need the data in how it's stored in the database. We need to format it. So we'll just say format data. Good news, it's synchronous. And then we can change the actual payload to be what we delivered. Okay, so far so good. The issue is that we've got now 2 side effects. And unfortunately, they have to happen before we can continue. So it's not like we can just do this, right? Because we need these other 2 things to happen. Or do we? Let's figure that out. So get some data actually doesn't need a validate user. What it needs is just if the user is legit. So we're pushing that side effect out. And we're saying, side effects are not my problem. I'm a pure function. Go away. The second thing is it needs some data. It doesn't actually need Dynamo to query it. So I don't need query Dynamo. I need some data. Cool. So now if I have the user is legit and some data, I can simply say, if legit, then actually parse the data. Otherwise, return a 400. So we've made it more efficient and more pure because now everything's synchronous. So we don't need this anymore either. So now it's back to a synchronous function that's pure. It takes in some event, which we don't need that anymore. Fantastic. So now we have less parameters. So this pure function that is synchronous is a lot easier to test because we pass in a Boolean value in some database-looking JSON that we got from Dynamo, verify it's formatted, and return it, otherwise done. So your next question is, all right, so this function's a lot easier to test. We're not going to write a test for it, but if you were, it would look something like this. It would be like the result of get some data is true in some, I don't know, JSON that looks like foo, bar, and whatever. And the formatter makes that look pretty to output to the user. Maybe it's an array. Ooh, yeah. Let's do an array. Make it look like really complicated so we can loop through it. So that's it. And then you just go expect result, expect. I hate when it code hints chicken functions that no one uses. Result.body. Actually, yeah, result.body to be some format. And that's it. That's your pure function. That's why we love testing them. They're deterministic. They always work. It's a lot easier to say false and test the other scenario. So, okay, so we've made it pure, but what does that mean by imperative shell? That's the pure core. This is our Lambda's core is pure. It's easy to test. Our actual handler itself gets either an event or context, but no one uses the context. So we'll just say event. It's always asynchronous. So we'll say asynchronous. We need to get it some data, and we need to get it that those 2 side effects. So let's copy the actual side effects that we need to give it here, which is validate the user from the event, and then validate some data, assuming that event is legit, from Dynamo, and return it. So get some data, and we'll say return some data from legit and some data. And get some data will return the object that API gateway expects, whether it worked and you got your data or you're not authorized, I'm not getting your data, right? And the interesting thing from some data is we could probably improve things is validate it's actually legit before we go and fetch it. And we can do that by improving the code later. But for now, this is very small, does the actual side effects, and then calls the pure functions. So you'll notice that it's really small. It's just setting up the side effects. This guy is doing the actual work, and this is what we're testing. How would you test this? Most people who don't do acceptance testing or integration testing or end-to-end testing would then say, well, it's really small, but I still need to test it. They would whip out the mocks and spies, right? And because this handler has to have the same function signature to make it work, they might even create another function to call this just to test it indirectly or do weird curry things I used to do back in the day. So I say from a pure core imperative, shell perspective, pure, totally use unit tests and get that working. Here, use acceptance tests. Actually go in your test completely separate from error test. It would be an integration. Actually go invoke the Lambda and then validate that it returns this as JSON from your API gateway. Even heck with invoking Lambda, call API gateway with a post and validate that you can get this value. Now, if you can't easily set up the data in Dynamo, yes, that's really hard. But you can still validate that it's a 200, that it can see the user, and that if you had data in there that you just manually entered by hand, it would work. Eventually, you'd want to automate that point too. So this is why acceptance tests are hard, because people are like, what do you mean automate data in Dynamo? Well, it's serverless. You can do ephemeral environments. You can do serverless deploy. A lot of these CI/CD things that most developers don't want to work on could really help their lives. So that's how you do it. And let's talk about, what does an acceptance test look like? Let's go look at our acceptance test here for just logging, for example. You would do the same thing for Lambda. So when you use Winston's going to log to a file, and it combines all your logs in JSON. It's almost exactly what CloudWatch looks like from a series of log messages that are in JSON, and you can open them and see the content. So we're going to use Winston to do this locally. This would work the same thing if you did Lambda on serverless, okay? So before each, we want to delete that log, and it's going to show up right here. So to show you, give an example what logs look like. It'll be a JSON format, and it'll have the level. So is it debug, error, warning, info, a custom one? And then what's the message? A lot of times they'll almost always have at least a timestamp. That's very, it's required for Splunk, it's required for Elk, things like that. And so it'd probably have a lot more information or metadata that we'd like to attach. And I think our test, if you had 8 hours, you could probably add all of them and it would look really good and you'd feel really confident about it. So we just added 2 for here for now. Just level, message, that's the default that Winston comes with. And so what our acceptance test is like, all right, what it should do is add, a debug test message to it, add it there. It should add our log error, but use a real Winston logger. So it's going to call Winston with the type of error and then give it our message, whatever that message is from the log error. Then we're going to add another one. So we should have a log with like 3 messages in it. And we just want to verify, okay, if we give it enough time to write to disk, you can force Winston, but I'm not going to spend time doing that. So if we give it enough time to write to disk, because it's a streaming node thing, we want to read it, convert it to a string because it's a buffer. We want to split a new line because each log is on its own line. We want to filter out the blanks because a lot of times the last one will be empty, or if somebody just put it in there. Go through each of those array items and then parse it. So if we have 3 log items, we'll have 3 parsed JSON objects in an array. We then want to verify, only get the error ones, things that aren't error we don't care about. And the one that we logged should be this. If it worked, we're good to go. So let's take out skip here, run it, and see if it actually passed. Cool. So it passed locally, and this should also pass on CI. Now, you'll notice I'm reading from file system here, where it's reading the combined log. My assumption here is that you would replace that, let's say for AWS, that would be using the CloudWatch log streams where you can read logs within a certain time window and filter those logs. Good news, those logs already do all this crap. So you don't have to parse them. They already come as arrays of JSON, which is really nice. Kind of. I think they're base 64 encoded. I can't remember. But you also wouldn't have to delete each time. You only care about logs in a certain time window based on when you start your test. So you could actually test, did my logger actually write? For this Lambda that we created, you would do the exact same thing, except you would do it from an API gateway perspective. You would actually write a unit test to call your API gateway and say, do I get a status code back? And does the body look like I expect? And again, there's only so much you can do if you don't have database automation in there, but that's okay. You're validating your Lambda still works and you're getting your status code. That's great, man. That means that this function is in really good shape. It's not throwing errors. It's fantastic. So that's how you do it. That's how you do pure core imperative shell, where you take your core functions, 99% of your app, as much as you can possibly do, and make it pure. As soon as you see some kind of side effect, put it in a parameter. As soon as you say, well, wait a minute, if that side effect gets me something and I don't need it immediately, right, then do it. Then one dude, the imperative part, when I say imperative, it's like very procedural code, very, very how it works, right? You make it get those side effects, do the actual side effects, and give it to your pure functions. That way, the only time it really is going to break because of your tests is this guy. So that you also know where your error handling should go, where your extra logs should go. When things break and you panic, where do you look for problems? Probably right there, because that's where the side effects are happening. So it's a lot easier to narrow down versus having side effects everywhere. So see how we put validate user and query dynamo up in the function like that? If you start seeing function handlers that have massive amounts of side effects, whether you're using test-driven development or not, that's where you want to look. to say, if there's a way to like push these side effects out so somebody else can make it a problem and have this guy do 20,000 side effects, that's how you get it done, man. So before we go, let's talk about the UI portion of that, because I think from a React perspective, people get very confused on what that looks like. So from a React perspective, hooks are actually a side effect. And the reason that a lot of functional people didn't like them is because the hooks have a lot of strange lifecycle events behind them. They create side effects. So you know how, for example, if you go to like, let's say JavaScript array, and you type in JavaScript array and you get this list here, some of these array methods cause side effects and some do not. So for example, find will return if it found something in that array, the item of it, or return undefined. It doesn't actually modify the array, right? Whereas things like, let me see if we, like push and pop, they modify the actual array. So not only do some of them return a value, but they also modify the array you messed with. So they have side effects. In React, hooks are very similar. Some have side effects, like use state and use effect and things like that, can affect how often your component renders. They affect how you can test it. You can get yourself into trouble with conditional logic, where runtime, thankfully, React will tell you if you have more hooks that were created than last time. So it's not idempotent. So little things like that. So bottom line is hooks are side effects. And a lot of us functional programmers get really uncomfortable when we start seeing a lot of these hooks at top, because it's the exact same thing as we saw with the other function where we had two side effects. And we're like, ugh, get out. We push it up, make it somebody else's problem. And so that's why you want to do this legit version of it where you pass them into there, because from a unit testing perspective, all I have to do is pass in a Boolean and some silly little setter that like changes the value, and that's it. So from a testing perspective, if you've ever looked at testing the React testing library and seen what it takes to set up a hook, it's a lot of work. It's a little bit more than creating a stub, and you have to use their native stuff to do it. You can't. It's not like Jest where you can emulate that stuff in JavaScript. You don't need to use Jest, but you know it helps if you want to use it. React testing library, you have to use their hook stuff, right? It's how the React components work. And so you're forced to use their mechanism for their custom style side effects, right? To test your basic component working. If you don't use it and just do pure components, you don't have that problem. And so you basically push the side effects or the hooks higher up and let somebody else deal with it, which means that the smart components are really, really small. They're just injecting hooks and you're good to go. So from that perspective, that's what you want to do. Now, many of you might know I'm a Redux fan. I think Redux solves all these hooks problems because you have determinism in, just like you do in Elm, you have a single object, and 99% of your functions, although there's a lot, even with Redux Toolkit or Easy Peasy or any of the other wrappers, they're pure functions. So the only time you ever have problems is like in your components, interactivity or CSS, which is fantastic. You know what tests those really well? Cypress. So that's your acceptance test. Cypress can actually use the app. All the pure functions are like 99% Redux. It's a really good combo on the front end. It's almost the exact same combo that you would use on the back end, right? Where you don't have mocks and things like that on the front end. You just test all your pure functions in Redux, even with your thunks, right? If you're doing asynchronous calls, HTTP. And then the rest of it you test with Cypress using whitebox tests. So if anything breaks, it's usually from a race condition of going different places or a certain Boolean wasn't set. Really, really easy stuff to do if you're using test-driven development with Cypress. So Redux has the same problem because they try to capitulate and say, look, originally Redux was built using hooks. It was slow, so they refactored it out, but they still provide hooks to integrate with larger applications because eventually you're going to use hooks, right? Or are you? Hooks, again, even in Redux, are side effects. So you can push those to the side too to make your components more testable. So if you don't want to use select or use dispatch in every single one of your components and you want to test those components, are they rendering correctly? Are they doing the logic correctly? Then you can do that. You can push those to the side again, and eventually your smart components are using the Redux hooks or the regular hooks or the use state. And the other thing too is that I've made it very black and white here, but the world is gray, and sometimes you accidentally either fall back to habits, another developer does it, or you're just tired, or you don't have linting rules for it. And you may use local state. You might have a use state in there mixed in with Redux, and that's okay. But the point is you have that same attitude of pushing it up, and that smart component at the very, very top does all the Redux hooks or the regular hooks, okay? So that's imperative imperative shell style, where you do all the side effects at the top and the rest of your stuff is pure. And I hope I'll drop the links to these articles that you can peruse. I think they're a really good testing technique. So again, if you're wondering why we do this, it's because pure functions are really easy to test, and they have some wonderful capabilities of being very deterministic. It means they always work. They're very predictable. They're a lot easier to debug, and you don't have to rely on whatever third party is doing something that's out of sight, right? That's a wonderful behavior. And so it makes, as time goes on, 2 months, 3 months, 6 months, 8 months, your code becomes a lot more maintainable because the stubs that you have to do sometimes to get those things to work are very small compared to a lot of these mocks that require a lot of setup. And as soon as you change the innards of your function, maybe it uses a different side effect, the mocks are a lot harder to change than the stubs are, just because they're bigger, there's more of them. And so it makes your code easier to change. And that's usually the best measurement of good code. Is it easy to change? Using pure functions and testing those pure functions, those are a lot easier to change. How do I know my app works? Well, you're going to use an acceptance test for that. And if you're using acceptance test, there's not really a reason to use spies and mocks for the most part. There are certain cases where if-thens, validate it. But on the large, they're the ones actually using the side effects for real. And so your acceptance tests kind of cover everything else your unit test didn't cover from a mock and spy perspective. So hope that helps. Hope you give you an idea of why pure core imperative shell is a wonderful technique, regardless if you're an FP or an OO programmer. You just focus on making 99% of your functions pure. And your unit test, as you start injecting more dependencies, you start realizing, maybe there's a way to push these out to make it somebody else's problem. You have the imperative part that you're testing with acceptance test, not unit test, to handle all the side effects, setting them up, and then inject them into the function. So again, you can use this on front end, back end, doesn't matter. And you got any other questions? I'm Jester Excel on Twitter. I'm on LinkedIn, Jesse Warden, and you can drop a comment on YouTube. I'll see y'all next week.